Let me introduce our next speaker, which is Cheryl Seeger from the from the Missouri Geological Survey. And Cheryl attended the University of Missouri-Rolla for a bachelor's degree, a master's degree, and a PhD degree, and she discovered all geology during her bachelor's degree and never looked back. Exactly the same as me, actually. So, after a brief stint in oil shales, she has been with the Missouri Geological Survey for nearly 40 years, starting with an internship during a master's degree. She and her unit currently are working on multiple grants related to critical minerals geology in Missouri, and now she's going to be talking about how the USGS Earth MRI initiative is being implemented on the state level here in Missouri. So let's welcome Cheryl Seeger, and thank you for presenting, Cheryl.
Yeah. David was a little taller than me here. Okay, so hopefully I'll figure the pointer out here. Why Missouri, the Missouri Geological Survey, and Earth MRI? And for those of you who aren't familiar with it, Earth MRI is a USGS-funded program that is the Earth Mapping Resources Initiative, looking at critical minerals within the U.S. So part of why Missouri, out of the 50 USGS-listed critical minerals, Missouri either has current mining, past mining, or known occurrence of 30 of them. In addition, there is also a Department of Energy critical mineral list for minerals critical for energy production. And of the 18 minerals on that list, Missouri has 13 of them or can produce them. So Earth MRI is giving not only Missouri, but states across the country a real opportunity to be able to better understand our critical mineral resources within our individual states. So in Missouri, all of our major metal and barite districts either have produced or are known to contain critical minerals off that list. And in addition, all the waste sites for all of those districts also have critical mineral potential, as do our coals and coal wastes. The critical minerals are located within multiple deposit types within the state. And found the pointer. They're primarily located in either Mississippi Valley type metal deposits, which are in southwest Missouri or southeastern Missouri, iron oxide apatite, iron oxide copper gold, which the district is shown in green, as well as in a variety of sedimentary deposits throughout the state. Another advantage to Missouri is that due to our infrastructure within the state, as well as the industry that's already here and developing, we have potential to do cradle to grave. We can do everything from produce the raw materials to process them to come up with a final product. And that can also include recycling of materials as well as waste material reprocessing. Missouri also has a very strong mining industry, both metals and industrial minerals. And because of this, there's experienced staff already in the state who can be tapped to work on projects. And in addition, we have the resources available here at S&T. And Missouri overall has a good balance between being an industry-friendly environment as well as having good, strong environmental and reclamation protections in place. So just quickly, our mission is to provide earth science information and services that support stewardship and beneficial use of Missouri's natural resources and that benefit public health and safety. So within that mission and looking at critical minerals, our role in that falls into what difference can we make on critical minerals. First and foremost, like most geologic state surveys, we have a very strong understanding of the geology of our state as well as what potential critical mineral resources are available. We also absolutely love to learn more about the geology of the state. That's our only focus, really, at the state survey. We also have a mandate to make all of that information available to the public, to everyone. And we are currently working more on looking to identify future resources for when technology changes. And this is going to include both looking at prospective areas for future mineral production as well as waste materials. Also, like everyone else, we have to balance our resources. Nobody, whether you're in university, government, or industry, has unlimited staff, equipment, money, everything else. We're all tied into that. Funding kind of becomes one of the first priorities. You can't do anything else without the funding, but within that, we work very hard to produce good quality products and again, get them out to the public. We're also very lucky in Missouri that we have a governor's office, state legislature, and DNR leadership that recognize the importance of critical minerals to the state of Missouri. In addition, the National Bipartisan Infrastructure Law has also been very supportive, as that has increased a lot of funding coming into the Earth MRI program. So between our state agencies and the bill law, we're able to look a lot at being able to have future jobs and job creation, create domestic sources for critical minerals that help with our U.S. security, and do a lot of collaboration between industry, government agencies, and universities that hasn't always been available to us. So where do state geologic surveys fit really well into all that collaboration? We are great at boots on the ground. We're great at getting out in the field and collecting that raw data and making it available. And this is just an example of some of what we've been doing for critical minerals. Those boxes all represent quadrangles where we have done or are currently doing bedrock geologic mapping projects, most of which are funded by Earth MRI. It includes parts of the St. Francis Mountains, shown there in brown, as well as the Cobalt District in southeast Missouri. And when these mapping projects are completed, we will have more than 700 square miles of new bedrock mapping for southern Missouri in a critical mineral important area. But sometimes our boots aren't always taking us out in the field. Sometimes they take us to our core repository, which I'll talk about a little bit later. Also takes us to file cabinets that have existing data in that we're working on making available. Any of that data, whether it's new or historic, we have a mandate to make available to the public. We work our best to provide it into different usable formats, and we use multiple publication mechanisms. Again, as a state geologic survey, we have staff that have expertise in multiple geologic disciplines. We also have staff that have experience in working in multiple different commodities. Since we work statewide, we aren't limited to working in a specific mining district or trying to produce a specific commodity. Because of this, we can do a very wide range of projects, which you'll see on an upcoming slide, as well as a lot of these Earth MRI projects require the ability to do multiple different geologic disciplines. And just as an example of that is geochemistry. There are multiple Earth MRI projects that are specifically aimed at collecting geochemical data for a specific set of commodities in a specific area. But we can't just go out and grab a sample and say, hey, look, it showed this much cobalt. That tells us absolutely nothing. The person collecting that data also has to be able to describe the rock it came from. Was there any mineralization visible? Was there any structure there? They have to do the whole package while they're out collecting that geochemical sample. On the flip side of that, there are many Earth MRI projects aren't specifically geochemistry aimed, but include a geochemistry component. And again, for example, all our new mapping is including collecting new geochemical data, as well as some of our data preservation work we're completing. So this is what we're doing right now, or have done in the past. We have completed and have ongoing several Earth MRI bedrock geologic mapping projects, as well as a previous pre-Earth MRI project and one that was done under the USGS State Map program. We have participated in or are leading 3 multi-state geochemical projects funded by Earth MRI, and these are looking at critical minerals in Pennsylvania black shales, geochemical sampling in the tri-state district with Kansas and Oklahoma, which, feeding off the past talk, does have known gallium germanium in it, and over on the east side of the state looking at critical minerals in ore division phosphate deposits. We are also just wrapping up a project working with U.S. Department of Energy, looking at coals and coal waste streams for rare earths, again, primarily in northern Missouri. We have funding from the U.S. Forest Service for geochemical sampling in the Lake Killarney Quadrangle in southeast Missouri. Under the USGS Data Preservation Program, we are doing data scanning, data entry, and starting a core photography project. And mine waste also came up in the last talk. We are currently doing a statewide inventory of mine waste throughout Missouri. We are also currently working on geochemical sampling at P Ridge, which is the purple X right there, thanks to working with Caldera Holding. And we will be starting this fall a chat and waste rock sampling project in the, it's hard to see here, Old Lead Belt area, working with the Doe Run Company. As a state survey, we have been around for 171 years. I'm just going to toss out, I did the math the other day, I've been around for 23% of that. I got to retire someday. Whoops, sorry, apologize for that. We have 171 years of physical samples. That includes drill core, hand samples, files, field notebooks, all kinds of data. If you're wondering why we might care about something that got described in 1870, that's because it may be talking about a critical mineral occurrence or a mineral occurrence that could have critical minerals associated, and that's the only reference we have to it that lets us go out and find that site in the field today. So we do use this material extensively, and we are working on getting a lot of it digitally available. We also have cores, cuttings, and hand samples, which I'll mention on the next slide, as well as more than 2,000 thin sections. And just as an example of some of what we're doing through data preservation, that's Earth MRI funds coming through USGS data preservation. Over the last few years, we have added 5,000 well logs to an existing database we had that already had nearly 5,000 in it. And USGS and other agencies have already been using this for three-dimensional modeling as well as geophysical studies. Part of that has also been adding any geochemistry associated with those. That database now currently has more than 240,000 individual elemental assays contained in it. I always kind of view the McCracken Core Library as sort of the gem of the Geologic Survey. We have one of the larger core repositories in the mid-continent. It contains more than 1.2 million feet of drill core and more than 6 million feet of drill cuttings. Many of these cores and cuttings are from areas either with known deposits, known mineralization, or in critical mineral prospective areas. And again, USGS, industry, other agencies have come in and used this data to help them develop three-dimensional frameworks. We also have a hand sample collection, which has many historic samples in it. A lot of these are from old mine sites that are totally inaccessible now, and this is the only physical existing data left. And we're working with Earth MRI on getting a lot of this data available. And this fall, we will be starting a core photography project as well. Earth MRI is also giving us a lot more opportunities for collaboration with a lot of other groups. And these are just some, this is not all, this is just some of the different agencies we have been working with, both from the original, here's in situ resources side, up to here's how this could affect economic development within the state. Some of our newer collaborations include working with S&T on a minerals concept guide, working again with Caldera Holding and Doe Run on evaluating mine waste potential within the state. And of course, the Tech Hub got mentioned earlier, which has really helped build a lot of relationships across the state with groups that maybe weren't specifically aware of critical minerals to start off with. It's also giving us the opportunity to hire interns. We love interns. Interns get so much work done for us. But it's giving them direct exposure to working in the geologic field, as well as exposure to economic geology, which they may not have depending which school they attended. Finally, again, mine waste. This has been a newer facet of Earth MRI the last few years. So our main projects here are identifying any mine waste with non-fuel mine waste within the state. Current sampling projects at Pea Ridge and starting this fall in the Old Lead Belt. Just wrapping up, documenting coal wastes within the state. And all of this is also giving us an opportunity to look at what potential we may have in some of our other waste materials within the state. Again, everything we do gets out to the public. And it's giving us a win-win because anytime you can reprocess material that's already above ground, it's going to be less expensive for the company. Also, maybe you don't have to ship materials as far, possibly less of a carbon footprint. So in summary, why Missouri? Well, we have potential for quite a few critical minerals within the state, both within in situ resources as well as currently existing mine waste. Ourselves, plus other state surveys, are generally the people with the deepest understanding of the overall geology of their state. We're collecting and publishing a lot of new data, as well as getting a lot of historic data available, and we're also using that historic data during our current projects. We have the ability to work on multiple commodities, as well as in multiple geologic disciplines, which again is important because Earth MRI projects don't tend to focus on a thing. They tend to be very broad. It's giving us an opportunity to better understand a lot of critical mineral resource potential within the state, and it's allowing us to increase our collaboration with other entities. And even though we've been here for 171 years, we are always looking to the future. Most of what we're doing is built on what geologists those past 171 years have done, and we're just trying to build a good foundation for future geologists. I have to give a big thank you to USGS, Department of Energy, and U.S. Forest Service for providing funding for these projects, Caldera Holding and the Doe Run Company for giving us access for mine waste, and Missouri S&T also providing assistance on one of the mine waste projects. And I absolutely have to thank the staff in my unit, as well as my interns. They're the people keeping all of this rolling forward. And special thanks to Carrie Bridges and Jerry Pruitt for providing some information for this presentation.